Joining us today, joining us is Dr. T.V.S. Vinay, Vivek. Dr. T.V.S. Vinay. He is an assistant professor at Dhaka University.
Shreya, check your audio.
Uh, Hello.
Yes, now it is audible, Nana. Start.
All right, ma'am. Thank you. So,
Shreya, are you there?
hello, ma'am.
Yes, Nana. Voice is audible. Start, Nana.
All right, ma'am. So, good morning, everybody. Sorry, good evening, everyone. Welcome to the fourth day of Atal FTP. And today, joining us is Dr. TVS Vivek, who works as an assistant professor in ICFI with an experience of 12 years. He has completed his postdoctoral in 2020, and today he will be enlightening us on the topic Vigilant Plant Health Monitoring. Sir, the stage is all yours.
Yeah, thank you, ma'am. Can you able to hear everyone? Can you able to hear
Yes.
my voice?
Yes, sir. Audible,
Yes,
sir.
Vivek, sir.
Yeah, thank you. Thank you for confirming. So fine. A very good evening to one and all. So I hope the introduction has been given by one of your colleagues. So I'm very happy for it. So I'm going to share my screen, and today's I'm going to speak about on the theme of vigilant plant health monitoring. So I'll be giving you some important points and some of the inputs and what criteria to be taken care into consideration, and what are the objectives. And finally, I'll be giving you some sort of points which are very important for applying to the proposals. Okay, in the coming days, I mean in the next coming months, we have many more proposals which are opened. I'm going to share up my screen here. And please confirm me once you can able to see my screen or not, so that. Yes, can you please confirm is my screen?
Yes. Yes,
Yes,
it
sir.
is.
Yes, sir.
Yes.
Right. Okay, right. Thank you. Thank you for confirming. Thanks a lot. So the theme that is given to me is about vigilant plant health monitoring. Right. So before I go in depth into the slides, I would like to quote the points. Okay. See, the key to securing our future lies in integrating the smart technology. Okay. So the key lies in integrating the smart technology by taking the help of raw data. Okay. Historical knowledge. That means the knowledge which is gained from the previous years. And we are not only going to take the raw data and knowledge, but also our experience. So our experience is also going to help us, okay, how to keep our plant, okay, our plant health in a very good condition. All right. So I would like to say you one point here. If you take a plant, okay, and that plant also thinks like a human, I mean the human beings. Okay, they try to communicate their struggles through visible signs. So plants also communicate their problems and struggles through visible signs. Okay, so that is the reason why how the horticulturist mainly questions on two aspects. The first one is what is wrong with my plant? Okay, what is wrong with my plant? And the next question is that in future, how my plant is going to look. So these two are the main important questions which not only the horticulturist should answer, but taking the technology from computer science or from the allied branches of computer science. See, nowadays, no, we got many more concepts, many more techniques, okay, to keep our plants, crops, and to visualize our and to see the predictions and detections. Okay, so in this perspective, I would like to say you that ensuring the health of our plants is a paramount in protected environment. Okay, so major applications you are going to find in the hyperspectral images. Okay, hyperspectral images are mostly used for plant health monitoring. And you can ask me that why I'm going only for the hyperspectral images here is that the key point in considering the hyperspectral images is to reduce the plant stress. See, once if you try to reduce the plant stress, automatically there will be a lot of increase in the production quality as well as quantity also. Once if you try to reduce the plant stress, okay, you can automatically increase the quality as well as the quantity. And the key point to be considered here is that by taking the help of these hyperspectral images, okay, it's becoming very easy nowadays. Now, see, we are not only going to use the hyperspectral images, but we use the low-cost mechanisms or techniques with the help of infinite fields. And we are also going to consider the water level, soil quantity, and the presence of pathogens and pests. These are also very important because the flies or the pests or the pathogens, these are the organisms which are going to affect the plant. Okay, not only from its leaf, okay, even those are going to be affected through its stem also. Okay, I mean the stem node also. See, when we were doing our postdoctoral fellowship from the foreign university, we used to concentrate not only on the plants like leaves or this one. We used to take the whole scenario into consideration. Okay, that is the main aspect what many of us forget here. Now, next, how you can optimize your crop field. Okay, see, by taking timely actions. Okay, you can also by taking the timely actions to adjust your growing environment, and you need to decide when and where to use the resources and inputs. This is the most important criterion. Okay, very important criterion, when and where to use the resources and inputs. And depending upon these points only, you are supposed to take the investment decisions. See, all these are continuous chain process. Okay, taking the timely actions. Okay, second one is to decide when and where to use your resources. Okay, and once if you concentrate on these two aspects, okay, the investment from this you need to derive. You can easily derive the investment decisions. All right. See, monitoring the plant health by optimizing your crop yield. All right. Next. So if you see a small cycle here, first of all, you should have a clear vision. Okay, clear vision of before starting of any sort of this one, you should have a clear vision. And in this clear vision, you need to consider many more aspects like who is the supplier, what is the different what is the different material you are going to use, and what are the different production costs, and what exactly is the product, because as you know that the plants can be classified into different categories or different types, like type 1, type 2, type 3, hybrid. Nowadays we are getting many more dual hybrids also. Okay, and who are going to benefit it, like the stakeholders, the customers, most probably which type of customers will be benefited. So the person should have a clear vision. Okay, before start of any sort of this plant when this one he should have a clear vision. Okay, how he is going to carry forward. And next one, in advance he is supposed to predict, okay, he is supposed to predict the process, that like what type of steps to be taken care into consideration. So the predictability has to be done from the user end. Okay, that means he has to plan, okay, pre-plan all these process, all these steps. Then once the idea is set up, then he is supposed to act with agility. So as we know that in software engineering, agility is the concept where the engineer or designer tries to, okay, remodify or redraws the architecture or redraws the software. But here, while coming into the real scenario of this plant health monitoring, okay, we need to act. I mean, the user has to act with very agility. That is the most important, because what happens here is that sometimes the graph may grow to the top end. That means he may get a lot of profits, and sometimes the profits might be very less when compared to his predictions. So he has to act with agility, and this process is the rotating process. That means it's a cyclic chain. So once after reaching to it, again he has to think about the next step. Again, he has to has a clear vision of information about that plant. Okay, and again he has to think about the supplier, the materials, the production, the product, and who are the persons going to get a profits, or to which persons we can able to derive this all these things. Again, so this chain will automatically continue. Right? Next, let us see what are the different steps. Okay, so I would like to give you the different steps in optimizing your crop yield. Okay, so we have three important steps in optimizing the crop yield. So the first step mainly speaks about detect early signs of plant stress. So this is the first step which mainly speaks about. So if the plants are so stressed, okay, if the plants are so stressed plants reduce the production capacity and have long-term consequences. So the user has to take care about the plants. That means the plant should not be stressed here. You are supposed to measure and compare the climate with agronomy data. See, here comes one more new term, the agronomy data, to find the relationships. So you need to find the relationships. Okay, for example, to improve the production quantity. Okay, so to improve the production quantity, we can compare the plant temperature and ambient temperature. So the plant temperature, okay, and the ambient temperature can be derived from either the radiations, humidity. Okay, so by taking these factors, you can able to derive that values. Okay, so the first step here is to detect the early signs of plant stress. This is the first step, first and the foremost step. Okay, if you detect as early as possible, okay, if you detect that the plant is getting some stress in the early stages, then the output what you are getting will be totally different. Like you may not even expect, okay, you may not even expect that the health of the plant, that means it will be in that much of good condition. That's why while you are taking the next steps, first of all, in the early moments itself only, try to clarify that whether the plants are facing any stress or not. Okay, and I would like to say you here that we have different data sets. We have different data sets for finding the plant stress. That means you can able to detect the signs of the plant stress by taking different data sets into consideration. So I have listed some data sets here. And if you see here, one data set is like Pangea, where it concentrates only on climate and environmental data sets. See, this data set purely concentrates only on the climatic aspects as well as environmental aspects. But from this data set, you can able to derive the climatic data. So this is the link that I have. So this is the link for getting that website of Pangea. Okay, and depending upon the climate and environmental data sets, all types of variations, all types of attributes that comes under these two aspects are going to be available in this data set. So these data sets, to some extent, they are freely available, but upon requisition, okay, so they will be providing the data set as of whole. So the main reason of considering these data set or this type of data set is that you will be getting the real-time analysis of your real-time analysis of your idea of your plant. See, our main motto is to see that our plant should be in good health condition. So for that, what are the different scenarios and case studies we are going to take? Okay, so that is what we are going to see in this lecture. And the next data set is about given by the Indian Meteorological Department. And this data set mainly concentrates only on the climatic aspects. Upon the requisition, you can able to get the data sets. And one point I would like to say you here, so I don't know, that might be faculty, many of you are from the faculty fraternity. So if you are applying for any sort of proposals, okay, the proposals that comes from the government, okay, private or non-government, I would like to suggest you that before designing the algorithmic aspects, first of all, try to check whether particular data sets are available to continue with your project or not. Why I am telling you like this here is that, see, IMD, Indian Meteorological Department, upon request of your proposal abstract, surely they are going to provide you the data set. But what I would like to say you here is that try to involve the scientists who are working in that area from IMD. I'm telling you, see, they'll be giving you some inputs. Those inputs will be very helpful for you to continue with your proposals. And there is one more data set named as India government data set. Okay, in short, we call it as OGD. So these data sets mainly concentrates only on the crop production and soil health. So what are the different attributes that are required for crop production and soil health? You can find in this from this data set. And apart from all these things, okay, we have ICRISAT also, so which gives crop and soil data sets for precision agriculture. So from this, you can able to easily get the data from Indian Meteorological Department, Indian Open Government Data, and ICRISAT. So from all these three, what I would like to suggest you is that try to get the inputs from the scientists and be very particular with your what we call abstract and objectives. You should be very particular. Objectives should not, and the data set should not be changed at all. So once if you decide this data set is suited for this application, you can go for it. See, I was following the previous sessions also regarding this plant health monitoring and smart farming, everything. See, many speakers have given about different types of sensors or different types of actuators like that. Even though for sensory data also, they are supposed to depend on the data set only. Okay, and even though, you know, Microsoft is one of the company which Microsoft mostly loves, okay, the crops. Microsoft mostly concentrates on the farmers. You know that probably every year Microsoft opens its proposals only to the farmers. That means what type of technology and how to leverage the technology easy to the farmers. They mostly concentrate only on the crops and the plant health system. So to what extent we are going to make our crops, okay, so sustainable in nature. And a very good application that you can develop is that actuators. You know, see, a small robotic hand, okay, a small robotic hand can able to give the lot of information to the farmer about their field. That means the farmer will be having some acres of land. Okay, the farmer will be getting the lot of information about his land, like what will be my asset. How much profit can he predict, and how much quintals can he able to get from it, just by taking a small actuator. Okay, and you know one thing, nowadays we are designing many drones. Okay, drones is also one of the good application, but when compared with the drones, actuators is one of a very good application. You can try to program the actuator very easily, where if you leave that actuator in that field, okay, in that crop field, it will automatically goes scans each and every inch of that land, and it tries to give the information to the farmer. So not only tries to give the information to the farmer, if there is any sort of defect in any plant, what is the defect and what is the pesticide that is to be given to that defect, and that actuator will also give information to the farmer that around 20 to 30 kilometers range in this shop, that pesticide is also available for that plant. So it not only gives the problems, but also it also informs the farmer, okay, about what pesticide and where it is available, and how much quantity of pesticide to be mixed, and when to be kept. So sometimes what happens here is that we are supposed to spray the pesticide within 2 to 3 days. Once if you delay, what will happen is the plant health will be deteriorated drastically. Okay, by in front of our own eyes only, the plant health will be deteriorated drastically. That's why it gives information within 2 days. Within 2 days, try to give the pesticide to this plant by mixing this type of materials. Okay, so that's why data sets are also going to play the most important role in detecting the early signs of plant stress. Okay, so but the most important point, what you are supposed to consider here is that you need to measure and compare the climate with agronomy data. So why you are going to compare the climate with agronomy data means you are going to find the relationships. Like we have so to continue further, first of all, you need to find the relationship between this between the climate and agronomy data. So to get that, so these are the different data sets where you can find this information. Next, in the second step, okay, you need to optimize the resources and inputs. So what we are going to do in this second step here is that, see, the main in this step, the main goal is to visualize key agronomy data, trends, and insights across all the sites. So the main goal is to visualize the key agronomy data. So understanding the light patterns will help us to identify the peak growth periods and optimize the resources, such as staffing for picking up. So in the second step, you are going to optimize the resources and inputs. And the most important outcome is for plant production. This helps us to choose the most effective time to spray. So to spray the chemical also, there is some time. Okay, there is some statistics that is present behind this optimizing the resources and inputs. Okay, by taking this step into consideration, you may come to know that how many staff you require to accomplish the task, how many staff you require for picking up the plant. Okay, and in the third step, you are going to enhance your operational efficiency. So the goal that can be achieved by enhancing the operational efficiency is to reduce the plant stress and improve the fruit size. Okay, so our main goal is to reduce the plant stress as well as improve the fruit size. So for this, we use the digital agronomy to support for investment planning and budgeting decisions. So by taking the help of this digital agronomy, you can able to achieve the planning for investment and budgeting decisions. Can be done very clearly without any sort of errors. Like like we can say that there might be some some errors, but the error rate will be very less. Okay, so for this we need for this to achieve this, I mean to achieve this, we need to do the fine tune the timing of whitewash application on air temperature inside the radiation. See, in front of you, there is a small image. Okay, so if you carefully observe this image is totally closed and surrounded with this one. See, this is where we are going to do the fine tuning, and see, the temperature and the radiation that is required for these plants is supported from these white meshes. Okay, so this step 3 mainly concentrates on the enhancing the operational efficiency. See, these are the 3 most important steps what you are supposed to take care in achieving, in monitoring the plant health, where you can easily optimize your crop yield. Okay, the monitoring the plant health. And let us see. So the next one we see about the plant health surveillance. Okay, so in this plant health surveillance, we are going to adopt some methods like anticipation, risk assessment, early detection, and multi-actor collaboration. So I would like to say you that this plant health surveillance can be divided into 4 thematic axes. So if you see the first axis, okay, in the first axis of this proposal, you are going to concentrate on the anticipation of pest emergence, innovative forecasting, and effects of climate. So the first step or the first axis mainly concentrate on the anticipation of pest emergence. So for some plants, no, the pests are going to come onto it, and it's totally going to destroy that. And you are going to see see what type of innovative forecasting you can do, okay, to get back it. So the first concentration or the first axis is about this. And in the second axis, you are going to use some of the surveillance tools. Okay, like we have some tools like imaging diagnostics, okay, including molecular or imaging diagnostics. These are some of the tools that comes under the surveillance tools. Okay, so from this you can able to see the graph of, that means the health of your plant in the form of a graph. Fine. In the third axis, in the third step, okay, you are going to see about the surveillance of known pests. See, in the first step, you are going to find that on what area the pests have damaged. But in the third step, you are going to see that what type of pests are going to affect this crop. Okay, that means the category of the pests. Okay, that is also most important, because from that only we can able to get what type of chemical or pesticide to be used. And nowadays we are getting many organic pesticides also. Previously we used to get many more chemical pesticides. See, I am the pure example in front of you, that when we were doing our research, okay, I am the person who have taken the chemical pests, and on the comparison, what I came to know is that when taking these organic pesticides, so even there is no damage to our hands also when you are using it. Okay, and in the fourth mechanism or in the fourth axis, you are going to find how is your plant health. That means to what extent the pests have been So in the fourth axis, you are going to find to what extent, okay, your plant health is. And from this only, you are going to do the management. Okay, so by taking these 4 axes, or by considering these 4 axes, you can able to do the anticipation, the risk assessment, early detection, and multi-actor collaboration. Yeah. So the next one is about the plant health monitoring using the deep learning. See, I won't discuss about any concepts what we have studied in our previous classes or in our previous pages, but I would like to introduce you to some new techniques. Okay, that how you can get your plant health. That means the health of your plant using deep learning. See, deep learning not only concentrates on the techniques, but one very important application that you can get from deep learning is you can able to find the nutrient deficiencies also. Okay, this is one of the very big major application. I'm telling you, if you can able to write, just make up a proposal on these nutrient deficiencies with the classification of deep learning mechanisms. And while you are implementing this in the deep learning, please don't go for the techniques that are available present in the market. Okay, present in the market means present in our syllabus. We have some techniques like convolutional neural networks. Please don't go for it. Okay, I see. I'm just going to introduce you to some other techniques, new techniques. Okay, try to implement them. See, the days are gone. Okay, previously we used to use many more techniques, but the old techniques. Now let us try to change the revolution of this plant health monitoring. Okay, this is a very good application of deep learning, the nutrient deficiencies. So as you know that, okay, convolutional neural networks, CNNs, mostly works on large data sets and recognize the complex patterns. And in today's session, I would like to introduce you to some techniques to classify the plant leafy images. Okay, especially the diseases or the problems that plant leafy images are going to get. See, the first technique what I would like to introduce you all is that about vision transformers, SWIN transformers, and capsule networks. See, these three are the most upcoming. Okay, the next era of deep learning is based is going to be based on these three techniques also, like the vision transformers, SWIN transformers, and the capsule networks. I would like to say one point here. If you see the mathematics that is present behind this vision transformers, SWIN or capsule networks, understanding the mathematics of these three concepts is very easy. Once if the data set is prepared, or once if the data set is ready, okay, and all the attributes in the data set are perfectly done, like what I mean to say is the data set is cleaned. I'm telling you, applying these concepts in the form of mathematics is also very easy, like taking these three mechanisms into consideration. See, vision transformers and SWIN transformers, capsule networks. You just make a note of it. In the next coming days, you can concentrate on nutrient deficiencies on the application of deep learning by taking these concepts into consideration. So why I'm telling you here is that as of now, until today, I would like to tell you, I can tell you that, okay, there is no much research on these topics. Now it is evolving. So this is the time. Okay, this is the time where you can able to focus on these three types of networks or three types of techniques, especially in the application of nutrient deficiencies by taking the deep learning into consideration. Now, if you see here, okay, if you see here about the vision transformers, okay, the main mechanism that is present behind the vision transformers is self-attention, because these vision transformers neither use the concept of convolutional neural networks nor LSTM, but these transformers builds a transformer model to outperform the existing methods. If you carefully see a small diagram here, you will be taking an image into consideration. Okay, that image is divided into different parts. Okay, once if the image is divided into different parts, and do remember while you are dividing this image, okay, you should have the clarity on what type of matrix you are going to consider, whether based on the size of the image, either you are going to go for 2 by 2 matrix or 4 by 4 matrix. So dividing the image into different parts, and once the part division is completed, okay, separately each and every part is given to the linear projection. Okay, in this linear projection, it is going to apply the patch as well as the position. So that's why for each and every input message or the input image, okay, small image, so the patch and the position embedding is done, and all these are going to be encoded into the transformer. Okay, so once it is encoded into the transformer, this vision transformer is going to give to which class. Okay, the ultimate output is it to gives to which class it belongs to, whether it is a bird, ball, car, apartments, buildings, or whether it is a mahal, or whether it is a road, whatever it might be. Okay, so here I am showing only the thematic structure, but if you carefully see the mathematics that is present behind these vision transformers, okay, I would like to say that these vision transformers mainly works on three basic attributes. The first one is the query, second one is the value, and the third one is the key. Okay, and if you take an image which is of three-dimensional in nature, then depending upon that x-axis, y-axis, and z-axis, you are supposed to consider the weights of those axes also. But even though you are considering the weights of those axes, it is very easy to write the mathematical formula for these type of vision transformers. Because vision transformers, their main motto is self-attention transformers. And if you see, yeah, this graph is very important. If you carefully observe this graph, okay, so don't think that this graph is the like it is the profit. Okay, see, this graph mainly shows about the proportion of concepts like vision transformer, wind transformer. That means vision transformer came into market from the year 2021. Okay, but unfortunately what happened is that since we have some techniques like DenseNet, okay, mobile VNet, V2, ResNet, I hope you have heard about all these deep learning mechanisms which we have in our core syllabus also. Okay, so I'm not speaking about these techniques, but I just want to show you that how the vision transformer graph is rapidly increasing year by year. And you know one thing, from this graph you can able to get some knowledge that, see, in the year 2024 there are some couple of research that is done by using this vision transformer. Okay, in the year 2025, there is some drastic downfall, and now it is again improving. But if you carefully observe in this graph, the swing transformer, okay, not all of the research work is going to be done on swing transformer. That means, okay, by using this swing transformer also, okay, you can able to find it out the applications of nutrients, okay, nutrient deficiencies in the area of, that means in the era of deep learning. Since wind transformer is having less amount of work that is to be going on, in this area also you can concentrate more the wind transformers, because see, I'm telling you, they are going to change the revolution of deep learning, all these the capsule networks also. Surely these three techniques are going to revolutionize the era of digital deep learning. Okay, so don't depend on the previous techniques. If you want to just implement, you can go for the comparison also. Comparison of these three, like vision, swing, and capsule network. So if you see this graph, capsule network, there are no papers. I mean, no research up to now. That is very good application. if you carefully observe this graph, see ResNet, usually many researchers are doing research on ResNet. Okay, and this research has been started around from 2015, from the year 2015. And now if you observe that graph in the year 2025 and 2024, there is a drastic downfall, a very drastic downfall is there. You try to observe this graph. See, this graph tells you, okay, gives you a lot of information that how important that these techniques are going to change the deep learning area. So you can see here in the x-axis, I have in the y-axis, I have taken the number of research, okay, that is done in all these type of techniques. See, all these are the techniques that directly or indirectly presents in deep learning. Next, if you see the capsule networks, see, the main principle of these capsule networks lies in the dynamic routing. Okay, so and these capsule networks are mostly based on the pose and the existence of detected entities. As I told you, okay, if you take these two techniques like vision transformers and spin transformers, these mostly works on like what we call plants, okay, or any sort of classification of crops also. But capsule networks, you can find the application in 3D also, I mean 3D imaging also. And you know, one good application and a very rare application of these capsule networks, it's nothing but visual question and answering. And you know, in the next coming days of these education, examinations are going to be, that means like manual examinations are going to be devastated, and we are going to get the visual examinations where the student will be coming to the college. He will be given some room. Okay, that means he's according to his enrollment number, he'll be given some room to write the exam, but he'll be writing the exam directly in the online. And the moment he finishes the exam, that moment itself only he's going to get a scorecard in front of him. And that moment itself only, by the end of the last examination, okay, he will be given one printout of mark sheet that he got obtained in that term examinations. So visual question answering is one of the very good application of these capsule networks. And one more point to be noted here is that you can take this visual question answering into your classroom lectures also. Like I have seen one application now, like so some of you has dropped a poll to answering that question. One question has been given to you. Okay, like that here digitally, okay, the student can able to answer the question in front of you only. That means there is no chance of malpracticing. And you know, by using these capsule networks, you can able to shuffle and reshuffle the questions also. So one student might be getting different questions, and his or her friend will be getting different question in front of him, or in front of his poll, he'll be getting different aspects of questions. So just remember that you have a lot of research in the areas of these vision transformers, spin transformers, and capsule networks. Okay, evolving area, coming up area. Okay, drastic change will be done. Lot of research is present, and one important and one research problem what I would like to introduce you in this what I mean to say is, using this vision transformers, is that there is one application, one very good application where we say that neuroscience meets cryptography. There is one application, and you know, see, since there is a lot of difference between plant health monitoring and neuroscience. See, I just want to quote one application here, one very good application of these vision transformers. Using the neuroscience of a plant, okay, you can able to design and draft And nowadays, you heard about artificial rice. Okay, chances are there that, okay, in future, you might able to see the artificial plants. And if you touch that plant surely will look like an original, the most original. Everyone can believe that it is an original plant, but uh, but in the reality, that plant will never and ever be the original. See, these type of applications, okay, the most concentration is only on the vision transformers. Okay, and yeah, see, I would like to quote some of the government agencies, okay, which are going to call for funding, especially in this area, like in the area of this plant health. Okay, so coming to the Indian government agencies, we have three important agencies. Okay, starting with the Department of Biotechnology, DPT. So this DBT regularly announces the calls for the research, mostly focuses only on the plant health, how you are going to take care of your plant and what type of mechanisms and what type of techniques you are going to implement. And the second Indian agency is that ICAR, Indian Council of Agriculture Research. And the main advantage of using this ICAR is that they are going to provide you with corpus fund. See, you will never and ever think about it. See, once if your project proposal is having that much of strong objectives, they are going to give you the corpus fund at a time. Okay, that much of importance they are giving on to the agriculture as well as to the plants. And the third one, as you know, that SERB, Science and Engineering Research Board. The problem with this SERB is that SERB releases the calls, okay, in all the areas of technology, not in one single area. But whereas the above two mainly concentrates on the plant health, agriculture aspects, all these things. But SERB also concentrates on agriculture, but not only on agriculture, with technology, agriculture, and with all the branches of engineering, including the physical and chemical sciences also. Okay, and they are going to ask the interdisciplinary work in the area of plant health. And if you see the international funding calls, dear faculty members and the research scholars, I would like to tell you that there is one international funding, especially only to the people who are staying in India. The name of that international funding is Nature Tech for Bharat. See, in the name itself, they are giving the name of that funding. I mean, that agency is Nature Tech, and they are going to give funding only for the Bharat. So Nature Tech mostly concentrates on nature-based solutions. Okay, nature-based. Nature means everything will come, like the climate. Okay, the crops, the plants, everything. The agriculture sector. Okay, and the environmental sector and how it is going to affect the society directly. So all these comes under the nature-based solutions. Okay, and natural resource management. So they concentrate on the natural resource management also, like the steps that are going to take care to implement the different resources and its infrastructures. So this is one of the international funding, but is given, but it is purely given to the researchers, okay, from India. So chances are there that if your proposal is having strong objectives, okay, so we can apply for this type of funding calls. See, the most important criterion what you should consider here is that when you are applying for funding, your objectives should be very strong. It is not like I'm going to use that sensor, and by using that sensor, I'll get this output. You must be very particular what sensor you are using, why you are using that sensor, why only that sensor. Or for example, why suppose suppose if you take our plants only, or if you consider our plants only, you must be very clear, like pinpoint clear. You should be there. That much of pinpoint they are going to expect from us. And not only these agencies, not only these government agencies like Indian government. See, this slide speaks about only about some of the Indian government agencies and international funding calls. But I would like to say one point: please don't confine only to this 2 or 3 agencies. But what I'm showing here is that these 2 or 3 agencies mostly concentrates on the plants. Okay, plants, agriculture, like that. There are many other funding proposals, but most concentration on plans is on these 3 fundings and these international funding calls. Now, if you see the private foundations, okay, even you can apply for the private foundations also. See, there are 2 private foundations. One is the Rainmatter Foundation. They purely concentrates on the climatic change, okay, like climatic change proposals and agriculture proposals. And coming to the SM Sehgal Foundation, they purely concentrates on water security, food security, and agriculture. That means SM Sehgal Foundation, I think now the proposals are open, okay, for agriculture. You can apply for agriculture if you have any sort of this one, like a strong proposal. And these are the private foundations. But the problem with these private foundations is that you should be very clear cut with the terms and conditions and with the objectives. Because the terms and conditions will make us to rotate in such a way that at the end, all the copyrights and the loss will be taken by their end. It should not be like that. It should be like in the form of a partnership collaboration. That is most important. That's why what we recommend, or even when we are dealing with the final year students of both BTech and MTech also, so we used to tell them that see, if you are doing any sort of project, okay, you are not only supposed to do the internship or project in that industry, but you should make them to come to our college, and you should call them for seeing the infrastructure. That this infrastructure also makes us to do the project successfully in our host organization. Okay, and the next slide. See, in the next slide, I would like to give you some objectives. Okay. So based on these 5 objectives, you can able to design one title, okay, and you can able to design one title, and you can also take these objectives and you can apply for the fund for continuing your research. So if you observe the first point that I'm going to take in this objective is that I'm going to take the aspect of deep learning, okay, which is based on the plant health monitoring system using image processing and IoT sensors. So here also IoT sensors means what type of sensor, what type of sensors, why only that sensors. Okay, in the backend aspect, you should have the clear-cut idea. And in the second objective, I'm going to deploy the drone-based and mobile app-based AI tools for real-time disease surveillance. So what is the goal, or what is the impact of this drone-based and mobile-based? Usually mobile-based, you can call it, it can be used for the farmers. And the drone-based, see, drone-based also, you should not design or develop a drone like in the form of like a big drone. Okay, your drone, the size of the drone and the infrastructure that you are using inside the drone also should fit this application. Next, the third step, as I told you, you are going to integrate hyperspectral imaging and deep learning models. So here I am using the vision transformers to detect the crop diseases early. And the fourth objective is to establish a farmer advisory system to provide actionable insights and reduce pesticide misuse. See, as I told you, one application, the actuator, the robotic actuator, okay, after scanning the crop, that means the field, okay, of a farmer, it is also going to give the whole information to the farmer. Okay, the whole information, that what type of actions he need to take in the future to accomplish that, to overcome that type of problems for his plants or for his crops. And it is also going to guide the farmer, okay, that how much quantity of pesticide to be taken, to be given to the plants. Okay, that means pesticide reuse will be totally eliminated here. And in the last objective, we are going to see how to improve the crop productivity by at least 20% in target areas through precision agriculture. So precision agriculture, the integration of all these things like drones, okay, imaging, deep learning techniques, or some other techniques. Okay, so all these are going to come in one family of precision agriculture. All right. So these are some of the objectives. Okay, now by taking these objectives into consideration, if you carefully observe here, in each and every objective, you are supposed to write, or you are supposed to do some back-end work. Okay, and after going through these 5 objectives, or some n number of objectives, from the objectives only you are supposed to derive the title of the project. The common mistake what we do nowadays here is that once first of all we decide the title and start working on that area, on that research area. It should not be done like that. First of all, you should have the clear-cut objective. First of all, you should know what you are going to do, what you are going to use, or what type of technology, or what type of subject you are going to implement in it, and how it will affect the society, and what is the impact. See, whatever you do, it should have a direct impact onto the society. Direct impact should be there. So I think tomorrow also I'm having one session. In tomorrow's session, for 10 to 15 minutes, I would like to show you one proposal. Okay, one proposal starting from how we write or how we conclude the abstract, and how the key terms to be taken, and what are the different techniques, okay, and how to adopt those techniques, we'll see. So I would like to end up my session here with this. So thank you. And please let me know if you have any sort of queries. I'm ready to give you the solutions.
Thank you so much, Vivek, for that insightful and informative session. We are truly appreciate the knowledge you have shared with us today. Thank you.
Thank you, ma'am.
Excuse me, sir. Hello.
Yes, sir. Yes, sir.
Sir, just have a query. Actually, I'm a PhD scholar. I'm working on plant leaf disease classification, sir.
Very good, sir. Excellent.
I just recently started working on it, but actually I don't know about these visual transformers, spin transformers. So I
Okay.
started with, as you mentioned, the technologies already using
Okay.
ResNet and VGNet. I was started working on.
Okay.
But with this session, I could come to know that they're better than those models are available.
Yeah.
Sir, could you please suggest us that resources for learning these visual transformers, like?
Sir, I
And
can support you, sir. I can support you that I'm having some like what we call some material. Like that material is not like PDF. What I would like to say you is it's a very easy material where you can understand what is the concept, actual mathematics that is present behind all these three techniques, like the vision, capsule, and SWIN. Okay, I got a material. I'll do one thing, sir. I just share that material with you, and if you have any sort of doubts in understanding that mathematics, okay, you just drop me that one. I'll try to explain you that equations, even very big equations also, it's very easy to understand, sir. Sir, it all based on the data set. That means suppose in your data set you have 10 attributes, I mean the 10 columns. Okay, and the rows, you have the row size is around 10,000 or 20,000 rows. Okay.
Yes,
so those 10 columns, how you are going to derive, I mean how you are going to denote those 10 columns in one small equation. Okay, that mathematics is very easy, sir. Usually what we think is that by seeing that big equations, we think that are a lot of concept to be studied. But once if you go dive into that, you will automatically say that nothing is there here, kuch bhi nahi hai. Once we need to understand this one, the concept.
Okay,
And
sir.
you know one thing, sir, if you
Yes,
use this in your research, what I would like to say you is that you take the vision, swing, and capsule and try to compare the results with ResNet. You automatically will come to know with your own eyes. You can see with your own eyes that how
Oh,
these three are performing when compared with ResNet.
so you mean like we can apply these three models for disease classification in plants?
Absolutely.
Oh, okay, very nice.
Absolutely. And if you think in
Yes.
a different way, I'm just telling you all these three techniques will become means continuation of your research work. It will become into the three projects.
Oh, really, really, really nice, sir. Sir, thank you, sir. Thank you very much, and definitely
No
I will
problem.
contact
No
you
problem,
through
sir.
mail.
No problem. It's
With
my
everything to share.
responsibility to clear your doubts.
Sure, sir. Thank you so much.
No problem. Thank you. Yeah, if you have any other questions, you can ask me.
In chat window, there is a one question.
Okay.
To check pest inspection through AI as these pests are visible, but how initial stages of pathogen attacks to be checked through AI? Question by Vikas Menon.
Um, I I couldn't able to see the question in the chat box.
Okay.
Yes. Yeah, I got it. It is easy to check pest infect. I think this question only through AI, these pests are visible. But how initial stages of pathogen attack to be checked? Pathogen attack to be checked through AI.
Yeah.
Easy to check the pest. Okay. So the question is raised by Vikas Menon, sir. Okay, sir. See. The problem here is that usually whenever we start the idea of this plant health monitoring, what we that means what steps we don't take care is about that uh, how pests are going to how pests are going to come, and how the pests will come to know that we are going to have an idea on this. And you are telling that it's easy to check the pest infestation through AI, okay, as these pests are visible, but not all pests are visible from AI, sir. There are some pests which you couldn't able to catch them through AI, and those pests will be entering not directly from the outside. Okay, those pests will be entering inside the plant uh, through the roots.
So, are there any other questions for sir?
Yeah, please let me know if you have any other questions.
I think that's all the questions we have for now, considering we're not getting any more.
Okay, ma'am.
Yeah, so thank you so much for your time, and thank you so
No
much
problem.
for
Thank
the
you. Thank you for
lecture.
giving this opportunity, ma'am.
Sure, sir. So, yeah, that's it for this session.
Okay, ma'am.
Yeah, we will be having our next session starting at 7:30 sharp. So, the participants, please stay in the meeting.
Yeah, sure, ma'am.
to start?
Yes, sir. Yes, sir.
So with this, I am going to start a discussion, whatever the little know in this domain or whatever I have learned with my experience working in this domain with more group as well as from the other person's experience too. I would like to say, so at any point if you feel you're not able to understand or any point you want to know something more details here, please feel free to interrupt me here. Correct? So with this note, I'm starting the discussion here. Before we go for sensors or craft using the drone technology, so it is very much desired here that we should know what is the current scenario of our agriculture situation in the India, and why the peoples are talking a lot about the sensors, IoT, or the drone technology, where the impact is coming in the present scenario. So just an very qualitative estimation is that in India, around 60 million tons, that is 10 to 12% of overall yield estimation here, which is costing us around $17.28 billion, is crop is destroyed every year here. So many times we are reading as well as listening in the news that many people are hungry and the people are going through a starvation process here. So if we can manage this chunk of wastage here, then it is giving a lot of possibility to cover up those scenario here. And if you go a little bit more detail in the crop wise, this destroyed amount, then we can say in case of rice, this is approximately 25%, 30% in the pulses, 35% oil seed, and approximately 50% in case of cotton seed here. So overall summary is, irrespective of crop, if you're moving ahead either from the north to south, this is a common scenario that this is the problem which persists across all the region here. And somewhere the number says just a matter. That somewhere it is high, somewhere it is low, somewhere it is moderate here. But everyone is being affected by this infestation here, or you can say due to the pest in the crop section here. So as for the context given to me, I have to confine my discussion here with this two aspects. One is the sensor, second is the drone technology here. Because once we go in the details of the losses, so there are many areas or many factors which are generally influencing or main reason that's why these losses are happening. So the question arises how we can minimize these numbers here, as the numbers are very big from the financial as well as from the mathematical aspects here. So we are trying to build something here or trying to develop something based on some of the latest development in the area of IoT, that is the sensors, okay, sensor based technology, and subsequently the drone technology here. Once we talk about the drone technology, having the drone technology itself, it is not the complete solution here. Nowadays, without AI, it is incomplete here. So during the discussion, I will try to set the context for the use of AI in the agriculture sectors here and how this drone technology and the sensor technology are going to be fit in the overall scenario so that we can get the maximum advantage and what kind of application it is going to be more and more useful here. So before we talk about the sensory data or the sensors here, let's try to understand how the IoT is impacting and what is the IoT in the conventional meaning sense here. So in general, it is saying, it is defined here that the IoT is the internetworking of physical virtual devices for the collection as well as the transfer of the data. So many times we are deploying the sensors, their main job is to collect the data here. But once you are collecting data, if it is present at the local node here, if it is not moved from that node to the higher node here, or you can say for the computational devices here for the proper analysis. So without analysis, this data is having no meaning. So if you see some of the popular scenario where the people are using the sensors for capturing the data, so it is just in healthcare applications where you can see some of the sensors have been deployed on the different body parts, right? And where we can observe, okay, that the ECG sensor is there, motion sensor is there, correct? So based on the movement of the people, all the data is being recorded, and with the help of the mobile phones, they are being transmitted to the cloud, and then they are properly analyzed, and based on the analysis, further decision part is taken care here. And if we see in the context of our agricultures, where these data can be very much helpful here, so there are tons of applications here. Okay, so especially nowadays, if we go ahead in the details, so a lot of buzz is there related to the UAV based agricultures here. How the UAV can contribute in the present scenario of the farming, right? And even if you're not going in that deep, so we can say the monitoring of the farm. Generally, for the monitoring purpose, manual inspection is being performed here. So it is going to take a lot of time as well as effort here. That task can be done very quickly with the help of the drone technology here. So monitoring is the area where real impact can be there here. If we integrate with the thermal sensors here, then 24 into 7 analysis can be sustained here. So precision farming, tracking and tracing here, overall supply chain management, correct? And the monitoring of the forestry. So once we see the agriculture here, so agriculture, there are different verticals here where the IoT or the sensory data is very much helpful. Based on their deployments, we are collecting the data here, and based on the collections, it is further being utilized. If you go a little bit detail here, so almost all the sectors which is being used here. In case of agriculture here, we can see the impact of sensors or you can say IoT is present there here. For example, agriculture systems. So from the crop growing stages monitoring as well their health forecasting as well their disease forecasting, all things can be done here, right? As well, if we see their life cycle of a crop here, that can be monitored here, that can be predicted here. Once we have the data for the entire life cycle, or based on their disease spreading level here, these things can be forecasted here, because most of us have some connection with the village area. So if you have that understanding, all of you have seen, generally the infestation or you can say the pest becomes dominant in certain atmospheric conditions here. So moisture level as well as temperatures or humidity, there are certain factors which is generally responsible for sudden growths or the spreading of the diseases here. So if we have that kind of data in the previous cycles, so that data can be used for the forecasting in the coming cycles here based on the atmospheric conditions monitoring here. So these are the possibility in case agriculture scenario. Once I am collecting the data here, correct? Once I have the access to the data, once I have the right access to the sensors here. So if I deploy it right kind of sensors to the right places here, then I can do the magic in case I have agriculture scenario here. So just the little bit detail about the sensors part here if I move ahead. So in general, generally people used to talk about the generic sensors such as temperature, humidity, moistures, ultraviolet sensor, acoustic sensors. So these sensors are being used primarily here. And based on the analysis of this, overall health forecasting can be done here. For example, if I say the acoustic sensor here, if there is some insect present is there here, and based on the acoustic, it can be done here. So there is at present some work is going on here, where we can see uh, generally a lot of grains is being stored at the warehouses here, and generally, if you go to the report as per the government of India, a major chunk of that stored grain is being destroyed here by the pest here. So at present, we have several technology where I can use it here. For example, if we can comes out with something handy or very portable device here where uh, it can be designed based on the integration of some sensors for the fetching the data if there is a presence of insect in the stored grain or not. That is the one aspect someone can explore it here. So again, the sensors. So all kind of sensors is not required for all applications here. For certain applications, we require acoustic sensors where the presence of insect can be identified by their acoustic. Okay, because just like a human being, all of you, when once we are speaking, a specific frequency we are generating here. So everyone has a unique signature of their sound. It can be clearly distinguished in case of a spectrogram if we generated here. Similar way, once we talk about the insect spectrogram can be generated and we can differentiate insects here based on their frequency, right? So the different kind of sensors will be required for these applications. Once you're looking forward for the health forecasting here, or you can say the ground, or you can say soil status, health status here, then the macro nutrients of the health will be required. So NPK sensors will be much more useful here. There the availability or nitrogen, phosphorus, or potassiums information will be much more useful here. Or if I'm looking forward for deciding what kind of crop is going to be useful in this kinds of geographical condition, so this information is going to be much more useful here. So once we are deploying the sensors, it doesn't mean I should deploy all the sensors at the field here. So what kind of field scenario is there? What kind of atmosphere situation is there? Okay, so accordingly, we have to select the different kind of sensors here for the deployment in the field. So it is a dynamic call based on the experience. We can select it here. And the very big question arises here: why this much sensors or IoTs in case of agriculture here? What is the main motivation factors for use of sensors in case of agriculture? So it can be understood by some numbers here. As per the Food and Agriculture Organization predictions, the expected growth of population to 8 billions by 2025 here. So to feed this numbers here, 8 billion population here, we required large quantity uh, of food here. So how we can sustain it here? So obviously we need to grow more, right? And for improving the yield or improving the growth here, obviously IoT based methods or precision agriculture is going to be very much handy here. So the proper analysis, I can utilize the resources effectively here. I can resources at the right time and the right amount here, right? So these kinds of additional features can be managed very easily here with the help of the technology. For example, if I say there is a moisture levels in the soil, so based on the moisture condition of the soil, accordingly the irrigation will start it here. So sometimes once you go to the manual inspection at the right time, the person observed it here, then it can be done here. If person misses it due to any reason here, it will be delayed. If you go for the pre-irrigation, it is going to again have certain other impact here. So use of the technology is going to be very much helpful, but for that purpose, we need to deploy the sensors in the field here, field day. And what were the argument we have discussed? This argument is also supported by the lot of studies which is available in the literature. If you go ahead, where this is suggesting with the help of the modern techniques or modern technology here, the agriculture sectors can be revolutionized here. Okay, and once we are thinking on that line, the idea is what were the manual processes are being present here. Can we comes out with some alternative version here or reliable version here with the help of the automation, okay, so that the entire process can be managed in automatic manners by taking the proper decision making process here. So as we go for the decision making process, the decision making process involves the analysis of the data. So that is the data analytics part. So where a large numbers of data scientists are required for the analysis purpose here. If you are not having, then obviously it is going to impact our analysis capabilities here. If you see what kind of areas where sensors can be deployed, okay, so in the context of agriculture, if you see, there are many verticals. Just for sake of reference, I have included few, where in the crop management, smart irrigation, but here what will be the amount of water is required at what time, that can be managed very efficiently here. The complete life cycles of the crop can be utilized here. So what kind of fertilizers will be required, what will be the amount of them, that can be decided very quickly here. If there is some pest presence here, what will be the medicines required here for the spraying purpose, what will be their associated quantity, can be find out very easily here. Soil conditioning, weather monitoring here based on the temperature, pressure, humidity, we can forecast it here. A smart greenhouse or a controlled environment agricultures, that can be also performed in a much better way with the help of the technology here. And as one of the example we have discussed earlier here, pest management. So that is something it is very easy to explore here with your students here, because for exploring this pest management part here, the simplest level as a proof of concepts, you can start with any of the microcontrollers by simply integrating few of the sensors, and then you can complete the identification part here. Because once we go for such kinds of managed system here, there are two very important aspects. One is detection, second is identifications here. Once we say the detection, means just identifying or detecting the presence of the pest here in the stored grain here. Subsequently, once I have detected there is a insect, what kind of insect is there here? That's the next part, is identification part here. So that is equally important, and we should give the focus on that part here. So with the technology, a remote operated irrigation system, correct? Okay, automation with the use of sensor and auto technology. In the last here, the drone monitoring, that is the area where a lot of potential is there. Nowadays, if you see, it's among all the verticals, drone is something which is coming very exponentially with respect to the growth aspect here compared to others, and is having a lot of potential to be exploited in the futures here. So that's why if the people have started thinking on that line here, that is going to be a very good area for the researchers to start. And our group have also worked on the drone technology. So I will share few of the finding or the outcomes of the groups. And once you see how is IoT integrated, then you can say from the starting at the ground level to the higher level also here, to the cloud services based here. At the different stages here, from irrigation, data analysis, image processing based here, climate control. Because once you talk about the data here, this data could be a sensory data based on the sensors in the form of signals. Other sensory data could be in the forms of videos or the images here. So all this data analysis required a lot of resources. At the backbone, the system should be compatible here, from the storage, analysis, as well as uh, trans transferring the data to the right persons here in the quick span of time here, or maybe more precisely, I would say, if possible, in the real time scenario here. If I can transfer the data in the real time, it is going to be much more impactful or the helpful here for the persons. The second aspect is, once we talk about the sensors, having the information about the sensor, deploying the sensors in the field here, and the capturing data is not the complete part. Okay, so until unless we are not analyzing it properly, it is incomplete here. So that is the area where the AI comes into the pictures here. And from the practical understanding, and the second factors which is propelling it for the growth here is the market. If you see some of the numbers here, which is very promising, I would say. And when you see in case of AI use, in case of agriculture sector, if you see, then it is estimated from US dollar 1 billion in 2020 to the US dollar 4 billion by 2026 here, at the cumulative aggregate growth rate of 25.5%. Okay. That's a huge growth rate here from a market perspective here. So ground level, there is a huge requirement for the data analytics part here, as well as the decision making part. And subsequently, the parallel growth in the AI industry is also one of the major factors which is responsible for the use of AI in the agriculture sectors here. Because if we see in the last 1 decade, the AI technologies have been strengthened a lot here. A lot, I would say. Because whatever the scenario was 10 years or 5 years ago, now if we compare at present here, there is huge growth here. And the way the market is mm, driving this technology here, in the coming next decade, this will be the complete era of AI. So any technology or any application can't be untouched without the AI here. That's the impact. And some impact is visible in case of the agriculture scenario here. And once we are using the tons of sensors deployment here in the field, then obviously we need a parallel ecosystem which have the compatibility to analyze it in case of real time here. Right? So once we are going for the analysis part, at that time there are two aspects there. One is the possibility for the real-time analysis of the data, as well as second possibility is, if I'm not in positions to analyze the real time, do I have the provision to capture the data here, and then later on I can analyze it and compute the information here, and then I can transmit or transfer it here to the cloud or the concerned person here. And at present, the government is also supporting a lot for the use of the AI in the different sectors, and especially agriculture sectors, because it is having the possibility to touch the farmers here. That's the main uh, area where the government is emphasizing a lot for their income increment here. So, as a researchers team, it is also our responsibility that whatever the growth is happening in the sectors, if it can be formalized in the some form where the farmers can be benefited here, then it is going to have a lot of positive impact on the society. And if I am going to utilize it in the proper sense, so obviously it is going to help in the yield estimation, as you can say, growth estimation here, the overall reduction in the damage which is happening annually here. And among all the sectors of the agriculture, as per the market strategy here, that agriculture sector is highest growth observed here in case of drone technology here. So drone technology is something which is promising us a lot with respect to the future. So we can think for that here as a researchers. If someone is starting some work here to explore in case of agriculture sectors here, then this could be one of the very promising area where to start it here. Because if you see the present scenario of the agriculture, then most of the processes are generally manual here. Either we start from the supervisions to the decision making process for everything here. Either if you see if there is some pest presence here, it is based on the person experience here. What will be the amount of chemical for the spraying purpose? It is again based on the experience here. And as an outcome of the many times it is observed, compared to the required amount, a large amount of chemicals is being spreaded here. Same is in case of potentials also here. And so fertilizers, we can see other areas where the farmers are giving more fertilizers what is being required by the field here. It is happening because in real time the awareness about the NPK availability of this organ soil conditions is not available here for everyone. Nowadays, many farmers are using this technology and they are uh, getting the advantage here, but this is not the case for most of us here. That's why still there is a huge scope. That's if we can come out with something handy or something portable, which can be helpful for the people who are working at the ground level here. And if you see the different sectors where the AI can useful here, along with the sensor data here, then starting from the crop sowing to the crop yield, different platforms, data, decision, actuation. Because if I am analyzing data, if I can take certain decisions here, so that decision should again be reflected at the ground level here. For example, if there is irrigation system, if I consider for the irrigation system, if I am continuously monitoring the humidity conditions or moisture levels of the environment here, so the moment it goes below the threshold, there will be automatic irrigations here. So that is a decision. One decision is based on certain threshold values. It should be informed to the system here. Maybe some kinds of alarming system here. For example, if there are some insect is there here or some rat etc is there here, if I have deployed some acoustic sensors in the field, so the moment uh, those rats or insects are creating a sound, so that sound must be recorded by the system here, and based on the analysis, that system gave us some message or some alarming here. So based on the alarming, the desired counteraction should be taken here quickly. So actuation part or this cycle, starting from the collection of the data to the decision making part, should be in the proper sync with the ground level realities here. If today is the insect presence, if I am informing tomorrow, so what is the point of that information here? So the real time analysis is one aspect where everyone can think of, whereas still a lot of capturing of data is happening uh, here, but the analysis is not happening in the real time. There are many constraints at present here. So whenever the constraint is there, that is the place for the researchers to come and fill that gap and comes with something which can be helpful for the farmers here or the agriculture sectors here. And if you see some of the areas, then we can say analyzing the market demands, correct? Minimizing the risk based on the forecasting or the predictive analysis techniques used here, breeding seeds here, or again sorting or selecting the right kind of seeds for the field. It is one of the area where the AI can be very much helpful, because many times once you visit the market for the seed purpose here, there are a lot of seed companies who are coming with their seed, correct? So which one is going to be best if I have some information here? Generally, if we visit the market, generally based on the people experience here, because last year I have used this seed, and the previous year this again next person who uses that company seed here, and based on the exposure here as well as the yield estimation, people used to take a call which one is going to be best here. If we can comes out with something scientific analysis where we can say these are the parameters or its input conditions, your soil conditions here, your atmospheric condition, this is the future forecasting. So against all these things here, this seed is going to be much more helpful here. So these kinds of analysis is not something for that we require the rocket science informations here. That is quite very handy here, but we need to plan it analysis in that line here, so that we can comes out with something which is useful. So protecting crops, where we can think of predicting the disease here, identify and remove the weeds, right, and recommend effective treatment of the pest here, right. So there is the pesticides. Monitoring soil health with the help of sensors, chemical soil analysis, right? That is going to be one areas where we can get the accurate status of the health of the field here. Feeding crops, identifying optimal irrigation patterns, nutrient application times here, harvesting, what is the right time for the harvestings here. So multiple areas based on the having the access to the data, these kinds of information can be obtained very easily by just having some computation here. So the combinations of these two, that's the sensors as well as the AI, that's something, this combination is going to be very much useful in the current trend of the technology here, because through the IoT or through the sensors, I have the access to the data. I can have the access to the data in the real time, correct? And once I have the access to the real data, I can't analyze it properly here in the real time. Then there is no meaning for that here. So that is the place where the AI comes here, because AI gives the opportunity for the proper analysis as well as the predictive analysis here. So where I can forecast based on the past data availability here. Because in principle, we all know it's the AI techniques are the data hungry. So for any kind of forecasting or the predictions, we need first the data. Once we have the data, the model can be designed, model can be tuned correctly, and then model can be tested, and then it could be implemented here in the real-time scenario. So there are many such solutions available in the market here, which is relying based on the composition of these two here. Either we talk about the census data or we talk about the imagery data here. All kinds of data is being fed to the system and they are being analyzed very effectively here. So once we are talking about the use of AI, then again as an individual, one technology is not sufficient, as we have discussed in the last few minutes here. Either we talk about
அக்செப்ட் ஆயிருக்கு ஃபுல் சாப்டர் எழுதினாதான் அதை வந்து அக்செப்ட் பண்ணுவோமா மாட்டோமான்னு சொல்லுவாங்களாம்.
Okay, so once we talk about the different combination of technology, so what we have concluded, this one technology is not sufficient to do the complete part here. So we need the support of other technology here. For example, as an individual, AI is not compatible. As an individual, IoT is not enough here, right? So we need a interdisciplinary kind of approaches here to solve some of the practical challenges which is being present in the real-time scenario here. So that is the area where the combination of the different technology is the need of the time, and that is going to be helpful. Okay, for the proper execution of the technology as well as I can say to use their potential for the best interest of the farmers here. Okay, so if we divide in very qualitative manner some of the verticals, so we can say IoT sensors for capturing and analyzing the data. And once we go for the capturing or analyzing the data, one sectors which is there. For example, if I deploy it in the field, so if I analyze it here, later on, how can I correlate this was the data or this is the finding corresponding to which locations? How could you know it here? For these cases, the minor check post is a minor check is that once I'm collecting the data, I should go ahead with the time stamping as well as the GPS stamping here. So these two additional information can help me to correlate the data at the later on here. Because if we have the GPS location, so I can correlate this is the GPS location and this data belong to this place here. And if I have the time stamping, this could also help me to correlate here. This was the time when I collected data, so this must belong to the this field here. So just the practical importance here, because once I'm thinking for a solution, so that solution should have all the basic inputs here, so that later on there not be any fuzziness in the outcome here. So later on we should not be confused that these outcomes belongs to which place here or which persons here. And the use of technology is going to be always with the better decision in a quick span of time here. And if you can minimize the error, then it is going to be a very much desired part here. Predictive analysis for the decision making, so where the data analytics part comes to be very handy with the help of the AI technology here. So it can be used in the irrigation, fertilizing, crop protection, and the harvesting, etc., etc. We have already discussed these possibilities. So the area which is very promising, we should devote some time on the drone technology here. So once we talk about the drone technology, it is generally used for the imaging, mapping, or surveying the forms here, right? Nowadays, a lot of buzz is there, and once we talk about the drones, so the biggest advantage is I can operate it from the remote places here. So in person, I need not to be present here at each and every instant of time here. Or if I have the field location, such thing, something like that, where the I can define the boundaries in the GPS coordinate system here. So I can decide, or I can assign the task to the drone here. So these are the geometry, or these are the coordinates boundaries here where you have to move on and collect the data, and then you can the task will be completed here. So these kinds of tasks are being performed here, where again we are going ahead with a lot of integration of the sensors as well as the GPS simultaneously here. So there are two basic classifications of the drones here. One is the ground drones, or the bots, we generally call it here. So nowadays these ground based bots are very useful, and a lot of companies are working in this region here. Once we go for the precision agricultures, then it has the possibility as well as the potential to be deployed. Okay, so many of the agricultures based company which are working here, so now they are looking forward for the solution in case of the ground drones also here, where the biggest advantage is in case of ground boats that they can have the better access to the crop. The reason is, once I am talking about the aerial drone here, aerial drone has a certain limitation here. Generally, 5 to 10 meters range, it is going to be flied here. Or if the pilot is very much expert, it can bring it to the 3 to 5 meters range here. But that is risky. Some things everyone can't fly in that range here. Even if you try to bring it below that range, then what will be the disadvantage? Your craft will be shaky due to the wing which is drone have. Uh, Due to that, there will be air, and that air will start the trembling of the crop here. So will not have the good capturing of the data here. So there is a certain practical limitation. So at least 3 meter distance, you have to maintain it. So once something you're collecting from a distance of 3 meters means approximately 10 feet. Or here, in case of ground drones, I can have a very close exposure to the crops here. I have a better access to the real-time scenario, or I can say ground scenario. For example, if I have to go for the weed detection here, it can be done. If I want to remove the weed from the ground, it can be performed very easily by the ground drones. If I want to identify the spreading of the pest or the diseases here, it can be done very easily here. If I want to uh, pluck the ripe crops here, then it can be also performed here. For example, tomato, brinjals, etc. here. So there are many ground boats which are available in the markets. They are performing such kinds of tasks here. The only constraint is they, based on their design, they should have the movement possibilities here. That movement corridor should be clear. Right? So if that condition is satisfied, this has a very potential solutions here. But once it comes to the Indian scenario, generally farmers don't like to keep the space between the two rows here. Okay? So generally our areas, we go for the dense farming here. So once it is dense farming, then the scope for such kinds of ground bots is limited. Then the scope potential comes for the drones here. And the biggest advantage in case of drone is they have the capability to survey the areas a very quick span of time. That is not possible with the ground bots here. So ground drone has certain advantages, aerial drone has a certain advantage. Everyone has certain limitations here. So that's why a hybrid kind of solution is going to be much more helpful based on the practical scenario. What kind of crop I'm looking forward, correct? For example, if I'm going for the cottons here, or if I'm going for the pulses here, then it is very difficult for me to move ahead with the ground drones here at the grown up stage of the crop here. But at the initial stage, this is can be helpful. So again, case-based case or the practical scenario, I can take a call which solution is going to be most fit for the agriculture purpose here. Just we have discussed. So once we talk about the sensors here, there are tons of sensors here. but I should not deploy all the sensors at all the places. Based on the applications, I should select a group of sensors here. Right. So similarly, when we're talking about the drones here, so drones have the multiple categories based on requirement or based on the scenario. I can select the drones which is going to be much more useful here. For example, if I am considering a drone for the surveying purpose only here, then in this case, I don't need a very big drone here. But if I'm looking forward a drone which can useful for the spraying or the irrigation purpose here, there is some pest presence, so it can go and spray the pesticides here. Then obviously, this kind of drone will be obviously bulkier in the size, right? And once you go for the spraying, there should be proper analysis, and this is the positions where a spraying must be there. Controlled spraying, I would say. It should not be random across all the fields here. So that is the area where technology, once I'm using it here, so that kind of precision must be bring here in the analysis part here. So again, that is the place where a lot of possibilities there, because once you start exploring the analysis of the data, drone data analysis here. So drone data analysis is something you can't find the good numbers here. Around 50-60% accuracy people are working. The moment you switch from the practical scenario, or you can say analysis based on the mobile based data, that number is more than 95%, even some cases 99% also here. So once I'm moving with the drone based data here, there is a certain constraint. Your conventional technology is not going to be fit here in that places here. So from the conventional approach, you have to think uh, something more. So we'll discuss in the coming solutions. Correct. Another vertical where we can use, that's the computer imaging, where the application of the cameras can be one of the areas. So based on the applications, we can deploy certain cameras at the different places in the form, okay, or I can connect the cameras with the drones when we are required. Drone have a flag and can capture the images here. So it can be used for the surveillance purpose also here, where the drone is flying in the different time intervals, and it is keep on analyzing the recorded images after different intervals. If there is certain change, it can be monitors and it can be analyzed it here further. So once we are going for the reality, because what we are generally discussing, this has the possibility as the potential for the larger impact on the agriculture sectors here with the help of sensors as well as the drone here. But if we see the ground real scenario here, so ground level person is the person who is going to use it here. Okay, the technology should be communicating with that person's understanding here. For example, if I'm going to deploy certain sensors in case of tractors here, if the lifespan of some tools is ending here, so that information should be pop up here. But the mode of that information which is coming to the person who is using it here, which should be compatible here, right? Generally, many times the information is available, but it is not in a regional language here. So that's why many people should not feel comfortable to connect with the technology. So this is one of the barriers. Because if you see farming here, farming is generally performed in the rural areas, village areas here, and there English is not something which is very much frequently being used. Or if you say even the Hindi, which is also not being used here, or other languages have the different scenario also here. So what are the standards we are using in case of technology? The same should be connected with the ground level persons here. That is my suggestions. That is much more helpful here. So where the technology have the possibilities here. So based on that, a lot of possibilities arises there here, and based on those possibility, within our small group, we have explored certain aspects here, and based on the exploration, I have tried to categorize them in the different modules, and I'm looking forward to have a discussion with you all what we have incorporated here. So our first work was based on the soybean rice dataset. Okay, and for this part, once we started, so I think this was 4 to 5 years ago when we got the acceptance of the proposal from the DST. And once we are started the analysis, then being in the region, Chhattisgarh here, the major crops are here, the rice as well as soybean. So idea was let's collect something which is much more useful for this region. Okay, in this project, one of our collaborator was Indira Gandhi Krishi Vishwavidyalaya. So they help us in the data collection part here. Because as a triple IT institute here, we are good in the data analytics part here, but generally what kind of diseases they are here. Okay, so at that line, we need certain expertise help here from the agriculture's background people here. So again, that is the area where people must think it here. If looking forward for the agriculture, so you must collaborate with some of the agriculture organizations, and there are a lot of possibility because once you have a discussion, you will understood the different possibilities here, right? So what are the real time challenges and what are the challenges faced by the farmers here because they are the entities or the bodies those are having the direct interaction with the farmers here on the many verticals here. But being academic institution here, our interaction is not happening on that dense manners here. So that was very much helpful for us here. And based on that, we have collected some data here, and based on the data, we have used the models, right? Trained the models here, and then we have tested the model using the deep learning techniques. These are some of the specification of the models, correct? So I'm going a little bit quick manners because my objective is to discuss something which is more linked with the drone technology. So this is just sake of reference. And the numbers which we obtained is, it was based on the mobile based images first. So it was quite good, more than 95% we obtained it. Rice output, we also explore it. Object detections, similar exercise in case of soybean, we have concluded. Second part was related to the interface creation. So for the farmer purpose, we have created the user app where we have to do some round of sitting with the farmers here where we have introduced our solutions and then a few of the farmers come ahead to adopt it and based on the adoption they have we have installed the app and then we are keep on having a discussion on the regular intervals here and with the collaboration of IGKV we are in a position to sort it out their solution. Another aspect of that project which we have explored was once they are interacting through the app here based on the crop selections, similar information are fetched from the Government of India e-Mandi websites here. So that was further helpful for the farmers here, where there are a lot of information related to that crop, price, and nearby facilities, nearby markets. All things have been fetched up to them here. Okay. So these were the part of. Okay. So third module is related to the drone technology, which is one of the area for the today's where we have used the drone imagery for the health forecasting of the crop here. So for that purpose, we have used the NDVI, right? So once you are using the NDVI, we are going for the simple indexing, and based on the indexing, we are trying to find out what is the present status of the crop here. Or you can say more precisely, I can say the health status here. Because when I say the NDVI, it is generally the normalized difference vegetation index here. So that index gives us the idea what is the health status here. For example, these are sample images collected from the IGKV test field here. So based on these fields, once I am observing data through the drone here, it is quite visible from this data here. Once we collected, this was the quite green. So once I am going for the NDVI, it is going to calculate some normalized values here. So that normalized value generally from ranging from -1 to 1. So if the values is -1 to 1 range here, then different meaning is associated. If it is towards the -1 side here, means crop is not healthy. If it is towards the +1 side here, means the very good crop condition it is predicting here, correct? So if the value is in between, then accordingly we can say this is the health status of the crop here. So this is very qualitative works here in natures. After certain computational exposures here, it can be managed very easily. And similarly, we have done it, and once we explore it, NDI's values which we obtained was in the range of 0.36 to 0.42 here. That is quite obvious because the crop is looking in the green niches here. That is its self-representation, the healthy status here. And for implementation part, we use the region-based segmentation. In the image analysis part, so K-mean clustering here. So next module, which I was based on the time available, I was thinking to focus on the module 4 and 5, which is much more be interesting for you all here. And where the idea was to use the drone imagery for the detection of mosaic virus disease in the okra plants here. Once we are talking about the image diseases in case of plant here, that is quite easy how to predict here once I'm using the mobile based images, because if you open the literatures here, you can find tons of informations here. There's no need to worry. A lot of models with exposure trained model, more than I think 95% is quite common phenomena here. But once it comes to the drone based imagery and you try to predict the disease here, that is quite challenging. Where it is challenging, because once you collect data, first thing is at least the range of 5 to 10 meters. That's the biggest constraint, because all the information you are collecting it from the long at the certain height, which is having certain impact here. So I would come to that part here before I would like to discuss this disease part here. So this is a very introductory discussion, information about the disease level in case of the okra plant. So what we have done, once we are going for the okra, so means ladyfingers, the crop here, and once you're collecting the data, many of you have noticed about this virus disease here. The vein sometimes grown up yellow, and it also thicken up here, right? So based on that growth of yellowness across the plant here, its overall yield is going to be decided here, or yield is going to be affected here. So our idea was, can we categorize this disease in the different scores here? Because once I do very qualitatively, because once we observe certain crops here, the disease is there, but very small portion of the crop is there. So ultimately, it is not impacting the yield. But yes, disease is there. One part we can see. Another idea is the disease is slightly spread up here, but still it is under control, moderate level here. Or the class 2, I can say, disease is spread to the point, but still it is not impacting the yield here, right? And the fourth is disease has spread up to the higher level here, and it is impacting the yield of the crop here. So that was the classification we have planned. So accordingly, we have to segregate the data. The idea was, first we are collecting the drone data for a bigger field size here. After collection of the data, we are going for the segregation of the data at the multiple classes here. So multiple classes segregation of data, that was one of the biggest challenge. At that time, we have to take help from the lot of agriculture's expert here in the classification part. And once we are in a position to classify it here, our task was again challenging, because the information which is lying here in the image, that is not very good visible to us here at the first place, because the images have been collected at least 10 feet height here. So extracting it properly. So first was the classification here. So means disease is there or not there. That's the first level of classification. So based on the problem statement, these were some of the challenges and also the flow of the work also here. First was the data set creation. So based on the challenge present in the data, I have to segregate the data as per the different clauses so that it can be used for the later on training purpose here. And for that purpose, once I am going to consider a patch size here, because generally the image which we are considering was corresponding to few acre size here. So there was a big crop areas. Against that crop area, there were different rows there. Against each and every rows, I have to detect it. What is the disease level here? So if you try to understand again, there was a certain bigger area across acres, half acre to 1 acre area. Against that 1 acre, there are multiple rows of the okra. I can say 80 to 90 or 100 rows of okra is there. In each rows, there are good numbers of okra plants here. So idea was once you are getting the image, that image was coming in the form of orthomosaic image here. So orthomosaic image is the complete image consisting of all the 90s or 100 rows altogether. So first task was go for the rows and plant detection. So once an input was given, that input image was approximately more than 1 GB. 1 GB image consisting of all the 90s rows, and that image was fed to the models here. The first task for the model was segregate all the rows here and then go for the plant detections here. Once that plant is done, detection part is done, the next task was binary classifications. Okay, so if the disease is there or not disease there, so means resistive as well as the susceptible part here. So as we have discussed, we have gone for the 4 categories here: 1, 2, 3, 4. 0, 1, 2, 3. So out of 0, 1, 2 here, we consider as a resistive part here. If the crop is coming in the first 3 category here, means crop is infected, disease is there, but this disease is not impacting the yield estimation here. That's why it is acceptable here, right? Once it is going class 3 level or beyond that level here, so it is considered as a susceptible here, means this crop is not useful for the analysis purpose here or yield purpose here. So that kinds of crop can be destroyed for the next cycles of growing here. So our next class was the multi-level disease detection. So first was the binary classification, resistive and susceptible. Next was further analysis related to the multi classes here. So the overall discussion is framed like this, where you can say first drone is there. Drone is collecting the data for all the images here, means all the complete half to 1 acre areas land where the okra is present. And against that, all the rows wise, it has been segregated. And against the rows, there is a proper boundaries there. Again, each and every rows clustering have been segregated in terms of the plant. So if you see the detected rows, next level, it is talking about the detected plants here after the yellow V7. Once we have detected the plant, next task was to find out it is resistive or the susceptible here, means binary classifications. So based on the binary classification, I have to segregate that plant is acceptable or plant is rejectable here. Once it is susceptible, it is discarded here. But once it is resistive, within that resistive level, I have to go for the further subclasses here. So multi-class category. So resistive level belongs to the level 0, level 1 or level 2 here. So there's a further subclasses in case of detections here. So this is one of the bigger pictures where you can see just a snip of the bigger pictures. So left hand side image is test image. After the first processing iterations here, where you can see some green boundaries against each rows have been marked here. Right? This is the first part here. So second, again, you see for each and every rows, it has been further marked with respect to their plant presence here. So each and every plant have been marked here. Now each plant will be categorized in terms of 0, 1, 2, and 3. But first classification was binary. So resistive and susceptibles here. So these are the initial experimental results of row detections here, where almost 90% accuracy we have obtained with the time, because it was quite challenging to get this numbers here, because sometimes the rows were overlapping to each others here. So we have to take the dynamic decision for the boundaries also here. Because based on the number of rows, because we used to calculate the average distance, average width of the rows here. So if it is overlapping here, then the width is supposed to be extended. So in that case, is that dynamic uh, learning is going to help us in framing the proper boundaries here, right? So again, this was one areas where the first phase we have to go on for some specific processes to ensure that the boundaries are formulated perfectly. Second part was the detection part, and then in this case, the first part where the plant detection was, we were almost 100% accurate. The next part was within that boundaries, the segregation of the plants here. So here you can observe the left hand side is the test image, same test image we are referring, and now we can see against each and every green boundaries there are some yellow green blue color boundaries here. So that blue color boundaries indicate the marking of the plants here. So these marking of the plants are helping us to have the idea. So these are the different plants here. That's the first stage of detection. Next task was against all such marking comes out with the identification part. So will it belongs to the resistive category or it belongs to the sustainable category here, susceptible categories here. So this is the test image. Against the test image, you can find out both kinds of boundaries, green as well as the blue, means row wise detection as well as the plant detections here. So marking is done, but it is not visible here. So we'll take zoomed version, yes, here. So here if you observed the same results, the zoomed images here. So now the zoomed image you can observe there are some notification like R and S, you can observe it here. There is the same image which we have used it, but slightly zoomed it for the better understanding, so that the model is giving all the outcomes here. For each and every plant have been categorized with R and S categories here. This is a resistive crop, this is a susceptible crop here. Similarly, from the others test image performed it analysis part. Here again you can observe the notation of R and S here. So this one, as you can see, little bit yellowness is there. So some marking with respect to the S is also there here, because the model was working based on the certain threshold value. If the values are crossing that level, then it is going to be S, correct? So decision was at the plant level, not at the leaf level here. So if there is yellow leaf in a plant here, it is not going to mark it as S. But overall, what is the overall contribution? Accordingly, R and S have been divided here. So R and S is for the binary classification. So that was the easy part which I consider among the overall solution part, if I consider here on the bigger picture of the problem statement. So, but after a successful many iterations here, so we are always improvement in the numbers, and with the time we also learned what are the challenges or the areas where we're lacking it, so we improved it, and the final outcome was very good. So ultimately, in case of binary classifications, our numbers were close to the 95 here. That was quite good in case of the drone imagery. If you compare the numbers with available data in the literatures here, you will not find these numbers here. So, and recently our group, we have submitted this work to the transaction, and the work have been accepted here in the last week. So now this work is available in the public domains here. So if someone is interested, you can explore it for this part here. So this work is available, And if you need any assistance or you need certain inputs here, you feel free to contact us here. The second task, which was much more challenging for us, was related to the multi-class classification. Once we are talking about the multi-class classification, within that resistive level, we are going for the certain subclasses here. Means 0, 1 and 2. As if the plant is very much healthy, good condition, just few portion of plant is having the image disease spreading here. That was the class 0. If it is moderate, then class 1. If it's level 2, disease is spread to the point where it is not impacting the yield here. That was our class 2. So still acceptable zone here. So accordingly, the crop have been categorized here 0, 1, 2 and 3 here. So now we can see based on the yellowish level, you can observe some of the plants have been marked as the level 3 here, correct? I hope all of you can see it here, because this is the zoomed image here. So where the numbers 0, 1, 2, 3 are quite visible here. So that was much more challenging for us here. So a lot of personalized training specific to the problem statement. For many iteration we have to do it. So, but after all the iterations, the numbers were quite in favor of us, which supported us to get the very good publication in case of transaction. So here again you can observe further a zoomed image for the further close observation here. So 0, 1, 2, 3 you can observe. And these plant level classifications were close to the 80% here. I think the data is not updated in the slide here, but this number are close to the 90% here, right? 85 to 90. So all the results which you are obtaining in case of 0, 1, 2 and 3 are in the range of 85 to 90 here at present here. So that is the numbers which is quite acceptable, because where we can rely on the outcomes here, right? So that was the part of learning, because a lot of exposures, practical challenges we have to face, and then we have to comes out with those limitations here. That was the one part here. And second very interesting project our group have performed, it was related to the crop yield forecasting here. Again, this entire project was based on the drone imagery here. Right? So for the yield estimation part, we have used the wheat. And all of you have noticed, once we go for the wheat crop here, so generally wheat crop have the lot of dense bunching here. Once you see the crop here, once it is grown up or at the stage of ripe up here, a lot of bunching is there here, right? Close bunching. And once we are talking about the yield predictions, so yield prediction depends on the overall calculation of the wheat head, correct? So once we are talking about the wheat head counting here, if all the wheat sets are very much separable here, then it is much more easy for me to count it here. But once I am collecting the data from the top, it is quite obvious that's all the wheat head will not comes into the pictures, correct? That's the one part, one challenge. Second challenge was in the data, once it is grown up, then a lot of bunching is there. Bunching in the sense, few wheat heads will be there in a very clumsy manner here. So if I am observing from the top here, so one wheat head will be visible completely, and other 3-4 wheat heads will be somewhere in the shadow of that part here. So I can say other wheat head will be visible 50%, few will be visible in the 20%, some will visible with the 30%, or so on here. So in the clumsy numbers, if I observe it, if practically if I see, I can see there are at least 10 wheat head here. But once this clumsy wheat head is fed to the model, it comes with 3 and 4s. What about those 5 and 6 numbers? There was a big misclassification or misdetection by the models the first stage here. So we have to use certain pre-processing aspects here in the model itself. First was by the use of GAN, correct? And second was the occlusion based here. Because occlusion based techniques is something which is used for hidden object identifications here. So once object is hidden, some portion of the object is there, then we use this kinds of technology to detect uh, the hidden object presence here. So idea was, first, what are the boundaries are available here? We should highlight those boundaries first, correct? Second, in case of occlusion based, what are the percentages visible here? Against each and every visible percentage, I can make it increase in the count here. For example, even if 20% is visible, against that 20%, a counting should be there here. But for that pause, even small boundaries should be marked by the model here. That there is a weighted, it must be counted. If the model miss it, there will be miss counting in the class counting purpose here. So that was the quite practical challenge once we have started working on this project here. Uh, so for exploration part, we have used the random cutout algorithm here, and based on the random cutout algorithm, we try to identify the different problems which we have just identified here. And then in case of dense data set here we try to comes out with a reliable outcome here. In case of reliable output here, we have to go for so many time and keep on changing the input data based on the problem being faced here. For example, first iteration we didn't think that we are supposed to miss it here. So after the annotation in a group, we have run the model here. But again, later on we realized there is a huge gap. For example, for every 1,000 counting, we are coming out with 700 something here. So there was a 300 gap approximately. There's a huge gap here. Then again, we have to go on for the bunching based specific data preparation here, where you prepare the data considering all such practical related like bunching, occlusion, everything here. Then again, the second iteration of model was done here. Then model comes out again with the better numbers. Then again, certain age-based detections here. Then these detections were much more helpful here. So the pre-processing was not relying on just one approach here. But in the background, it was relying on the multiple approaches here. I can say hybrid approach here, or multi-model approach, I can say it here, where the multiple aspects which have been explored in the literature as an individual here, but to solve the problems here, we have to come out with a multi-model pre-processing approach here in our solutions. So that multi-model pre-processing approach worked for us here, okay, and that was our crux of the entire solutions here, which finally work out and given us the final numbers, which were quite acceptable here. So in case of random cutout methods, there was certain stages we have categorized. First was center projections here for each and every weighthead which are countering. There was one dot we have created here, just selecting the random center. So one boundaries have been marked, their coordinates have been fixed here, x, y, z here. Based on the coordinate mapping, one center positions have been marked here. Correct. And later on, once we are going for the masking purpose, we have to be in proper align, because once I use the masking, later on, based on the counting power of the weightheads here, it must be mapped with the real optical data here. So a small mistake in the coordinates estimations here can lead to the wrong numbers here. So that was the one more challenge which we have encountered once we are trying to implement the random cutout method here. Because of occlusion categories here. So the mass projection should be properly once I'm going for the counting purpose here. So the proposed methodology in case of the counting purpose here, because the entire models depends on the counting. So what we have discussed till now, that was related to the pre-processing part, which we have included in the model. Now we are going towards the overall flow of the models here. So overall flow, if I see, there are the multiple stages which we have considered, correct? And proposed methodology was again like on the similar previous case. Again, we are getting the input image, that was the orthomosaic image here. This orthomosaic image again a big in size, more than 1 GB something here. Out of this 1 GB, again there was 80 to 90 rows against each and every rows here. First task was to go for the rows in the plant detection. So that's the first part here. So extraction part was very much accurate in the first place, where we are almost 99% accuracy. We are in a positions to segregate plant wise here. There was quite challenges, but with the dynamic approaches, we have adjusted the boundaries, and model was end of it. Model was giving 100% results to us here. The second experiment, so once I have demarked the boundaries for the rows here. So against each and every rows, there was a tiling approach here. So this was further break in the different image size here. For each and every image, we are counting the image, counting the wheat head. That against that counting, we are again stitching it. Correct? Stitching is with respect to the each rows here. And next stage of stitching was now after having the numbers corresponding to each rows. Now we are stitching all such rows here. So that's end of it. We are predicting the overall wheat head counting here. The overall that wheat head counting is useful in the prediction. So what will be the final numbers here? So if you see the scenario, the first is the orthomosaic image is given. Next stage was second plant identifications. So detection in terms of rows and their boundaries. Second was plot cropping. So each in every rows have been extracted. Against the extracted rows, next is it is the tiling. Each plot row wise have been further subdivided here in the fixed size here. For each and every small size, we try to calculate the wheat head count here. And after the counting every row wise, it have been stitched together to form the one rows. And against these rows, we have calculated the overall numbers by summing all the numbers through the different ties here. Then all the numbers should be in a proper sync. That's data from one tile should not mix of data of the other rows tile here. Right. So this is all happening in the parallelly. Right. So end of it, we are getting the complete solutions in the form of the given input image or as an orthomosaic image here. So again, the number was quite favor to us here, and approximately close to 90% accuracy we obtain in case of yield predictions also here. So these are the two very good projects where the real time research is going on here, where the contribution is going to impact the society as well as the farmers a lot here. Because for example, if you see the orthomosaic detection part here, the okra project, if I consider, where many times we used to go for the different seeds here. So very quickly I can go for the different seed showing here. Against that, what was the final outcome I'm getting it here? Yield I'm getting it here. What is the impact of the disease I'm getting it here? So all these cumulative factors can be exercised or can be recorded very quickly here, and accordingly it can be summarized here. So that's all data can be accessed very quickly to us here. Right? So in all such cases, the drone technology is very much helpful. Surveying or yield prediction, disease predictions here, because many of the work, if you explore it, is only based on the mobile imagery here. But now the time is coming where we need to move towards the drone-based imagery here. So that is quite possible because now we have the support from a lot of industries where they are very much helpful in providing the data here. You should have the right industries where you need to contact them here, and all this information you can get it here. So these were some of the references. I have used it during my presentations. So thank you. If you have any query, please let me know.
Thank you so much, Dr. Sri Vishal Tripathi, for that insightful and informative session. We are truly appreciate the knowledge you shared with us today, sir. Thank you very much, sir, once again.
Okay, madam. Thank you, madam. Thank you very much to all of you for having this much patience and listening to me for this entire long session. So I hope I have contributed something to your existing knowledge here. If you have any questions, you may ask it. It seems there is no questions to me.
Yes, sir. No questions, sir.
Okay. Anyway, no issue. So later on, if some issues, some points click to you here, you may reach out to me. You can search my profile, Dr. Sri Vishal Tripathi, at the IIIT Naya Raipur, Chhattisgarh here. Correct. And if you have any queries, you can directly email to me. I would try to answer it here. So, correct.
Okay, sir. Thank you very much, sir.
Okay. Once again, thank you to the organizers as well as the sir, Arvind sir also here for giving me session so that I can have interaction with you all. Thank you very much to all of you. Bye bye.
Thank you very much for your participation. Feedback form is shared in your WhatsApp group. Please give your valuable feedback.
That's only, madam. There is no
Yes.
any polls at all. Okay.
There is a no poll, ma'am.
Okay, ma'am. Thank you.
You can leave, madam.
Yes, sir.
Thank you. Thank you.